Hi, the Math Dog here. In this video I'm going to use translations and reflections to show the following trig properties. The cosine of x minus pi over 2 equals sine x. The sine of x minus pi over 2 equals negative cosine x. Tangent of x minus pi over 2 equals negative cotangent x. And then cosine of x plus pi over 2 equals negative sine x. Sine x of x plus pi over 2 equals cosine x. And tangent of x plus pi over 2 equals negative cotangent x. So let's get started. So here I'm going to show how to do a quick sketch of sine and cosine using the unit circle if you forget what, say, sine and cosine look like. So I have a unit circle, meaning it has radius 1. I've drawn a right triangle here. This is the coordinate right here, x, y. Okay. On a unit circle, this will be 1, 0. This will be 0, 1. This will be x equals negative 1, y is 0. And this will be x equals 0, y equals negative 1. Here's a right triangle, radius 1. Again, this is x, this is y. So from basic trigonometry, we have SO, COD, TOA. So sine is opposite hypotenuse. That's what SOA means. So sine of theta is opposite over hypotenuse. So sine theta from the unit circle diagram here will be y over 1, which implies that then y equals sine theta. Then cosine of theta, cosine is adjacent over hypotenuse, so cosine theta is x over 1, which implies from cross multiplication that x equals cosine theta. And then while we're at it, let's talk about tangent. Tangent theta. Tangent is TOA, which is opposite over adjacent, which is y over x. But y is equal to sine theta, and x is equal to cosine theta. So this is a very important fundamental trig identity, that tangent theta is sine theta over cosine theta. So now, using the unit circle, we're going to do a quick rough sketch of what sine and cosine looks like. But first, notice this coordinate xy also will be equivalent to x, which is cosine theta, and then y, which is sine theta. Therefore, that means that cosine 0 is 1, sine of 0 is 0, cosine of pi over 2, because this is 90 degrees, which is pi over 2 in radians, cosine of 90 or pi over 2 is 0, sine of pi over 2 or 90 is 1, etc. Then sine or cosine of 180 degrees or pi radians is negative 1, sine of pi or 180 degrees is 0, cosine of 270 degrees is 0, and 270 degrees in radians is 3 pi over 2. So then sine of 3 pi over 2 or 270 degrees is negative 1, and then you go back to 360 degrees or 2 pi and you start the process all over again. So we call sine and cosine periodic functions, because after you start here, you just could keep going around a unit circle forever, and it's going to keep repeating itself. Or you could go in the negative direction here, and it's just going to keep repeating itself forever. So sine and cosine are called periodic functions. Okay, so let's sketch the graph on the xy axis using the unit circle of what sine and cosine look like. So I'll do that in blue. So sine is 0, again, because xy equals cosine theta sine theta. Sine is 0, I'm going to start with sine again. So sine of 0 is 0. So at 0 radians or 0 degrees, you get 0. At pi over 2 or 90 degrees, sine is 1. At 180 degrees or pi radians, it's a 0 again. At 3 pi over 2 or 270 degrees, it's negative 1. And then at 2 pi, it goes back to 0. And it would continue to do this forever. Okay. Now we can go backwards too. I could start here. This is negative pi over 2. Sine of negative pi over 2, or negative 90 degrees, is negative 1. Sine of negative 180 degrees, or negative pi radians, is 0. Sine of negative 3 pi over 2, or negative 270 degrees, is 1. And then negative 2 pi, sine of negative 2 pi, is 0. So when we put this together, and if I wanted to put in other angles here, like 30 degrees, 60 degrees, 45 degrees, we would see this curve forming, but I'm not going to do that here. I'm just trying to get a quick sketch. So sine looks something like this. Okay. All right, so now let's do cosine, the exact same idea. So sine theta, I've done in blue. Cosine is also periodic, so I'll do that in red. So I'll start at 0 again. I'll do a positive rotation, which is counterclockwise. Positive angle rotations are counterclockwise, and negative angle rotations are clockwise. So cosine of 0 is 1. Okay, cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1 again. Okay, then if we work backwards, cosine of negative pi over 2 is going to be 0. Cosine of negative pi is negative 1. Cosine of negative 3 pi over 2, or again negative 270 degrees, is 0. And cosine of negative 2 pi is 1 again. So again, like I said on sine, if you took the cosine of like 30 degrees, 45 degrees, 60 degrees, you would get points that would show the curvature that I'm showing here. So you get a smooth function that looks something like this. And this should be memorized. And I'm going to use these functions in this forum to help answer the questions or derive the properties that I'm going to talk about in this video. So notice that sine and cosine are basically shifted 90 degrees apart, or pi over 2 radians apart. And that's how we're going to derive our formulas here. All right. So I believe it's absolutely useful to be able to draw a quick sketch of what I just did. So here's an example of what I mean by a quick sketch. So I go like this. This is 1, 0, negative 1. Put in some quick vertical lines. Okay, now I'm going to use radians. This is 0, pi over 2, pi, 3 pi over 2, and I'll go out to 2 pi, so I get one complete cycle of sine and cosine. Okay, then I'll go back here, negative pi over 2, negative pi, negative 3 pi over 2, and then over here I'll put negative 2 pi. Okay, so then I'll do sine. So sine will go boom, let's try blue, boom, boom, should be here, boom, boom, back this way. Okay, there's a quick sketch of sine theta. Okay, then cosine theta. So sine 0 is 0. Cosine of 0 is 1. So that is really helpful. Those two things to memorize. And then you can get the shape from there of the function, and you can figure out the values as you go through. So just following that pattern. So there's cosine theta. So now I can answer all the questions that for these properties that I'm going to do in this video from this basic sketch. Okay, so let's recall a horizontal translation of a function. So given a function f of x, the function f of x minus h is actually a shift h units right of f of x. You would think it should be left. I talk about that in a video on horizontal translations, but this is a shift to the right of h units. So if I have a function f of x, I shift it h units to the right, it looks like it's going to go like this. It's going to get shifted to the right h units. Given f of x plus h is a shift h units left. Okay, note f of x of negative h is f of x plus h. So again, x plus h is a shift h units left. So if this is my function f of x, I'm going to the left with this, like so. And we're going to use that fact in this video to derive these formulas. Now then we'll also talk about reflections. We're going to look at reflections over the x-axis. So given a function f of x, say here, negative f of x is a reflection over the x-axis. So they're a mirror image. Negative f of x is a mirror image of f of x over the x-axis, and we're going to use that in this video as well. All right, here's a graph of the four functions: sine x in red, cosine x in blue, negative sine x in green, and negative cosine x in yellow. So here at 0, sine x is right there, goes through 0. Cosine x, as I said a moment ago, goes through 1. It has a value of 1. So sine x is red. Notice that the green is a reflection of the red graph over the x-axis. So that's why this is negative sine x, because it's a reflection over the x-axis of sine of x. Just like the blue function cosine x, notice the yellow function is a reflection of the blue function over the x-axis. So negative cosine x is a reflection of cosine x over the x-axis, and again, negative sine x is the reflection of sine x over the x-axis. Okay, so we're going to use this graph to answer the questions or to derive the formulas in this video. So our first property that we're going to demonstrate is cosine of theta minus pi over 2 is equal to sine theta. Okay, remember this means a shift right of pi over 2. So first what we do is we find cosine. Cosine's right here. So I'm going to use cosine is right here. Okay, that's cosine of 0. So I'm shifting cosine right pi over 2. So that puts me right here. Okay, well what is that? That's sine theta. So that is why this property is true. There are other ways to prove this, but this is actually, I think, the simplest way. You can use the unit circle to do this. There's another way to do that. There's also some proofs with cosine and sine, but this I think is the simplest one. If you can draw that sketch of sine and cosine I was talking about a minute ago, right here, look, there's your cosine. So I have a different color here. I got the color switch from what I'm using here, but notice there's the shift of, so if I shift cosine to the right, pi over 2, I get sine, and that's what I just showed you. Okay, so now let's look at sine pi over, let's look at the sine of sine of theta minus pi over 2. Okay, well here's sine of 0. Okay, I'm shifting it to the right, pi over 2. Okay, that gives me right here, puts me right here. That's the yellow graph. Well, what is that? That's the reflection of cosine theta over the x-axis. So that's negative cosine theta. So there you go. That's why sine of theta minus pi over 2 is negative cosine theta, because that's what this yellow graph is right here. Let's continue. Show why tan of theta minus pi over 2 is negative cotangent theta. Well, let's go back. Let's get what we need here. So we know that tangent theta minus pi over 2 has to equal sine of theta minus pi over 2 over cosine of theta minus pi over 2. Okay, well let's look. Here we are. Here's sine. We know that sine of theta minus pi over 2, we just did that, is negative cosine theta. So this is negative cosine theta. Then cosine is right here, shifted pi over 2, puts you right here. Well, that's sine theta. Well, the reciprocal of tangent is cotangent, so this has to be negative cotangent theta, okay? Because cosine over sine is cotangent, okay? Let's continue. So now we're going to do cosine of theta plus pi over 2. So remember, again, the previous ones, I guess I should write that again. This is a shift right pi over 2. And this one, again, I use this fact instead of trying to graph tangent, which is a little more challenging function to graph, which you should be able to do, but we're not going to do it that way in this video. So again, let's go here now. This is plus pi over 2, so this is actually a shift left of pi over 2. Okay, so here's cosine. So I'm shifting it left this time to right here. Well, what's green? Well, that's negative sine theta. Okay, so that's why this is negative sine theta equal to cosine of theta plus pi over 2. Let's continue. So now show why sine theta plus pi over 2 is cosine theta. Well, this is a shift left of pi over 2. So let's start with sine. Sine is right here at 0. I'm shifting it left pi over 2, but look at that. That's cosine theta, so that's why this is true. Okay, this is our last one here. So show why tangent of theta plus pi over 2 is negative cotangent theta. So I'm going to rely on the fact that tangent is sine over cosine. So I'm going to write tangent of theta plus pi over 2 equals sine of theta plus pi over 2 over cosine of theta plus pi over 2. And again, I'm just going to look at my graph here. So sine of theta is right here. So sine of theta plus pi over 2, that's a shift. So again, this is a shift left of pi over 2. So I'm going to take sine, go to here, okay, and the graph that matches here is cosine. So this is cosine theta. Okay, then we'll do the same for cosine. So here's cosine of theta. So here's cosine of theta plus pi over 2, which is negative sine theta, the green function. So once again, this is negative cotangent theta. And this concludes all the properties for this video. I hope it was helpful. Thank you for watching. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. I would greatly appreciate it. You may share the content of this video with others.